to our first Lunch and Learn webinar in the series, where you will discover how to tackle signal and parity integrity issues in your application design. But let me introduce myself first. My name is Disa Sitar. I'm a marketing officer at Infinite Simulation Systems and the moderator of this event. But before we continue, I would kindly ask to wait 1 or 2 more minutes for everyone else to join, and then we're going to proceed further. So just 1 or 2 minutes, please. Okay, so let's begin. First, quick instructions on the webinar tool you're currently using. As you can see, you have many different options from the full screen mode, minimizing, maximizing the menu, raising a hand. But please, if you have a question, do not raise your hand. Instead, write your question down under the questions tab that you see below. As everyone is going to be muted during the webinar, the answers on your questions will be provided at the end. So again, don't raise your hand, please write your question under the questions tab. One more remark, this webinar is being recorded and the recording is going to be shared with you after the webinar together with the presentation slides. So today I'm joined by my colleague and application engineer Odysseas Votsis, who will tell you more about how to use Ansys simulation tools in order to solve signal and power integrity issues. Looking at the agenda, I will give you a very, very quick introduction on Infinite, and then I will give the word to Odysseas, who will take over all the following topics on the agenda. So who we are? Infinite Simulation Systems, we are Ansys Elite Channel Partner for the Benelux region, being active in computer-aided engineering for more than 30 years now. We are located in Netherlands. Our office is in Breda, which you can also see on the picture below. Having a broad product portfolio, that basically means that apart from electronics, we are active in many other domains, such as mechanics, fluids, optics, photonics, and more. Besides, Ansys simulation solutions are applicable across various industries and applications. Our main goal is to improve your design efficiency, but distribution of the simulation solutions, it's not the only thing we do. We also offer support and consultancy, and we organize practical and theoretical trainings where you can learn how to use these Ansys simulation tools in practice. The last thing before we continue with Odysseas is our new website. Here you can read more about everything I've just mentioned. So please feel free to scan this QR code and discover more about the solutions or blogs or trainings or anything you want to know. So thank you. Now we are starting for real. I'm giving my word to Odysseas and just enjoy.
Traditionally, companies have used a design, build, test, break, and fix design cycle. However, such an approach can be expensive and time-consuming. Furthermore, design rules and best practices may not provide engineers with enough guidance to properly design modern, cutting-edge products. By using simulation, virtual models and prototypes can be created and simulated, giving engineers more freedom via virtual testing. This will help engineers to have a better insight of their design, but also have a higher degree of confidence that the physical tests that they will make in the future will be successful 100%. Again, I cannot change the slide. I cannot change the slides for some reason. I will be asking you to change slides then. Okay, so if simulation is used as a design tool early in the development process, it can greatly benefit and cut costs. Here in the graph, we can see that with the traditional approach, the problems can only be detected when there is an actual prototype, of course. And to resolve them in that phase, it can be, first of all, way more costly, 100 times more costly than if we did it earlier, but also more time consuming, because you will have to wait for a new prototype to come, test it again, etc. But let's say that the problems arise even later in the development stage of your product, then the costs increase exponentially. Working with simulation tools early in the design phase, engineers can predict issues and work on solutions or changes very quickly, without the need of actual physical testing. This also shields out problems that might occur very late in the development stage, which would be, as we said, detrimental in cost. Now, let's talk a little bit about electronic design challenges. Next slide. So engineers must address a wide variety of design requirements when designing their electronic systems. This can range from electrical reliability issues such as signal and power integrity, thermal issues such as implementation of optimal cooling strategies, or mechanical issues, being able to withstand severe shock or vibration or drops. So engineers nowadays have to take into consideration a lot of things. Furthermore, products are expected to meet life requirements to ensure they meet their intended function for at least a specified amount of time. So we also have to have a lifetime reliability. Engineers need to finally consider the effects of manufacturing defects, transportation, and even product operation as part of their design process. Next slide. So, Ansys provides a suite of tools and workflow solutions that address this wide range of electronic reliability concerns. Each aspect, electrical, thermal, mechanical, and reliability physics analysis, plays a key role in understanding of how our electronic system operates and performs in a variety of applications. The scope of this webinar is to take a look and focus on these reliability elements one at a time. We will start with electronics reliability, today with signal and power integrity, and on our second webinar with EMI, EMC, electromagnetic interference and electromagnetic compatibility. Then we will do the thermal reliability analysis on our third webinar, and lastly, we will be talking about lifetime predictions on the webinars. Next slide. So what is power integrity? Basically, we as engineers have to make sure that the power is delivered reliably and efficiently to all of the components of our design. This is starting to prove more and more difficult to achieve in today's world. But why is that? As we all know, devices are becoming more complicated each year. There is a demand for fitting more components in a very tight space. There is also an increase in the frequency of information exchange. And at the same time, we have to have a higher functionality out of our device. These are all very major problems that the engineers have to tackle. This also creates a need for designing with account for power integrity from the get-go. Without properly addressing the power integrity of your device, this can lead to lackluster designs with electromagnetic interference issues, over or under delivery of power throughout your device, or even complete component failure if we are overshooting very much the power. Next slide. So Ansys is here with their simulation tools to help engineers mitigate the complexity of today's electronics. and also streamline their workflow with unprecedented accuracy. This will help you to boost efficiency and detail of your designs and be 100% certain of consequences before making a change in your design. It gives you freedom. In terms of power integrity, simulation can help you with easily evaluating your power delivery network, making sure power is delivered as you want without any surprises. It can help you extract all kinds of information quickly, like current flow, voltage, and impedance values, as parameters or TDR plots can be extracted very easily. But most importantly, it will give you the freedom to innovate and run what-if scenarios in a very short amount of time and very quickly. And this way, you can change and tweak your design to your needs. When it comes to PCB simulation, Ansys has developed a specialized tool. Next slide. And this is called the Ansys SI Wave. Ansys SI Wave is a hybrid full-wave electromagnetic field solver that is based on the finite element methods. It is highly specialized for PCB, but also for the electronic packages that lie within it. The main purposes of it is DC analysis, signal and power integrity, as well as electromagnetic interference in both frequency and time domains. Next slide. I want to focus here on that it was designed with one thing in mind: ease of use, ease of work, giving out results fast, but also being very accurate. These are the three pillars of SI Wave. It is a tool that is not meant to help you with designing the PCB per se, but rather analyze the full PCB. We will need to import the ECAD design that can come from third-party softwares as well into SI Wave and create a virtual prototype there with all of its electrical components already defined. Then the tool has several wizards to set up workflows and helps you, but also post-processing help and full view of your board, let's say. Next slide. So generally, the workflow of Ansys SI Wave is that you have a layout generated in ECAD systems like Cadence, Zuken, or Altium, and that you import inside SI Wave. A lot of these third-party softwares like Altium have a direct export for SI Wave, making the link between the tools very easy and very seamless. Then, once we have the imported layout, the hybrid, previous slide, the hybrid 2.5 full wave solver of Ansys SI Wave is doing the analysis for us, as I said, very quickly. This hybrid solver enables simulation of the entire system, both the PCB, but also the packages that lie within it. Then you can have some post-processing results, such as DC and AC analysis, resonant modes, or even full electrical circuit models can be generated. These analyses include IR drop, capacitor optimization, near and far fields visualization, and even we can couple with other physics solvers, such as thermal solvers, in which I will be talking about in our third webinar. This thermal solver that Ansys has is called Ansys IcePack, and the coupling between SI Wave and IcePack is also very easy and seamless. Next slide. Since it's a 2.5D solver, we can have results per layer of the PCB, per specific net of the PCB, but also across the entire geometry. Here in the pictures, we have made a DC analysis of our power delivery network. We can see that the power loss on a specific net on the left side, or the power loss across all our PCB on the right side. This information can help us identify how power is distributed on our PCB and help us see possible hotspots that might occur. Here on the left picture, you can see with the red that the power there is quite high, so there is a possibility for a hotspot. Maybe this is an area that we might focus more our design on. Next slide. So also via placement plays a big role when designing a PCB. Identifying the current flow and current crowding, as well as where high current vias are in our design can be essential for a successful product. All these can be easily generated in SI Wave, either with the help of wizards, or even we can define our own pass and fail criteria. I will talk about this in the next slide. Here on the left, we can see a table generated by SI Wave with our own criteria for via current density. We have specified this criteria, and we can see if the PCB will pass or fail this criteria for all the vias that are in our design. On the right-hand side, we have a full signal flow graph that is again generated automatically from SI Wave. This can help us visualize the path IR drop, as well as the drop across all lamped components. We can, of course, have similar reports for all different aspects of the design, such as voltage, current, or power limits. Next slide. So to summarize a little bit, we want as engineers to be able to foresee the future, and that's what simulation and SI Wave will help us do. We want to manage the peak power that might be on our board and see the whole power profile. We want to see how the decoupling capacitors and optimize them. We want to see the noise generated from the whole system. And with simulation, we can see all of this information very easily. We can obtain the full power distribution network across a wide frequency range. We can perform instantaneously power integrity analysis and maintain the transient supply nodes by optimizing both impedance, decoupling capacitors, or other things in our layout. We can do the what-if scenarios that we were talking about and easily tweak our design. And this will also reduce the iterations that we need to do on our actual prototype. As we all know, it's very expensive to make a prototype, make prototypes and testing the prototypes. And when these tests fails, it's not good for anybody. So by foreseeing the future, we can, with simulation, we can help mitigate all of these risks. Next slide. Now let's take a look on the other major electronic reliability issues, which is signal integrity. Signal integrity is basically data integrity. We need to have correct transmission and reception of the signals. So for a digital signal, a one that is transmitted must also be a one that is received. There should be no signal contamination. Now, we have continuously in today's world faster rising times in the standards of communication. Hence, we have higher frequencies that make the design much more complicated, because then we are not talking only about a wire passing through, but more RF domain. PCB boards are also getting bigger and denser, with closely spaced traces and even longer interconnects. This can lead to coupling and reflections that might not be easy to distinguish from the start of the design. This also, of course, leads to unnecessary crosstalk and also radiated emissions that will, first of all, hinder the performance of our product, but secondly, also might fail to meet the qualification standards that are needed in today's world to make a product. Next slide. I would like to highlight some of the more common causes of degraded signals on the circuit board from an electronic standpoint. The first one is a rather obvious one, that is signal attenuation due to the longer traces or the bigger stack-ups and the path that the signal has to take within the PCB. We have dielectric losses that increases with frequency. We have conductor surface roughness in the copper traces that also increase with frequency. So our life is getting more and more difficult. Secondly, we have reflection and interfaces, transmission between layers, vias, and in generally, any transmission along the line can cause impedance mismatch, of which, of course, in itself causes signal degradation. The last one that I want to talk about is coupling. Closely spaced lines or maybe external wiring on the PCB can have coupling and crosstalk effects that can greatly impact the signal. In today's world, things are becoming more complicated as the sheer amount of components and layers is increasing, making it very challenging for engineers to design with absolute certainty from the get-go and have clear insight without any further help. Next slide. And that's where simulation comes into play. It can help us visualize electromagnetic fields and resonant modes, determine how via and trace positioning will impact our signal, and maybe possibly help us find alternate signal routing. We can also, of course, generate very easily eye diagrams that will help us determine the levels of signal integrity on our whole board. Next slide. So as we're developing our board, we have to start looking at the electrical side and make sure that we identify any issues that would pop up and things that would be needed to be addressed early on. So with SI Wave, as I said, we can easily scan for these issues. Take a look at the left picture. We have done a crosstalk scan here, which is basically a one-click thing in SI Wave, and we immediately identified some parallel traces that are experiencing a heavy degree of crosstalk. Now we might want to change this. We tweak our design, we run it again, and voila, we can have a crosstalk scan without any problems. And we can also both see in frequency and time domains if these voltages are exceeding our own criteria and our own expectations as we have put them into the program. Similarly, looking at the second picture, we can make an impedance scan for all the lines and the traces on the board and see if they are within the limits that we have specified. Again, the impedance scan is a one-click thing in SI Wave, and here it generates a table, as you can see, that has with red impedance that are outside of our expectations, outside of our limits. Lastly, we can also look at the power plane, the ground plane, and all of the stack up to see if at certain frequencies we have resonant modes. These resonant modes might be even coupling with some active components that we have on the board, making it difficult to operate this active component. And also having more radiated noise through this. By extracting all of this information very easily in SI Wave, we can redesign our layout and scan again to make sure we have a clear design from a single integrity standpoint. Last slide. And lastly, I want to just focus again on a general thing of signal integrity. We have the tools nowadays to make signal integrity an easy job for us engineers, especially on the PCB side. We can have AC, DC analysis. We can generate TDR plots. We can see all the S parameters between the board on all the traces. We can have an end-to-end channel analysis. And we can also, of course, estimate the impedance and then delay of the transit waveforms. We have the tools to not only make our design viable and just passable, but also make our whole design and our whole board excellent. And that is how simulation can help you in today's world. Thank you very much for your time. I will give the microphone back to Tisa now.
So thank you, everyone. Thank you, Odie. Before we move to the Q&A session, just some contact details. So you don't have to write them down or anything because the presentation is going to be sent to you after the webinar. But if you have any questions, if you would like to know more about something, please feel free to contact us. We are here to help. And we also have a LinkedIn account. So if you want to follow us, again, feel free to scan the QR code and be updated on all the other events and happenings in the future. Now to questions. If anyone still has a question and did not write it down, please feel free, write your question down. We are going to answer. But let's begin with the first question, Odysseas, and this is how easy is to import designs? Does SCI Wave have a ready library of components?
Yes. So as I said, it's very easy to incorporate third-party softwares to import designs in SI Wave. As far as I know, that some third-party software have built-in tools. But even without that, but just by exporting ODB++ files or general ECAD files is very easy. And then, of course, depending on the information we have on these files, we might need to do a little bit of tweaking in the sense that if we have SIWave has a built-in component library with tens of thousands of components from various manufacturers with of course, very accurate values inside. But also, if we have some more exotic components, let's say, that are not defined in our ECAD files, we can do that in SI Wave. Also, some components that we might have built in-house, we can also have them in our library. You just make them once, save them, and then you have them forever. So yeah, I would say it's very easy to import things, and the already built-in library of tens of thousands of components from manufacturers that are constantly also being updated by Ansys makes our life easy.
Okay, thank you. The second question is, can I also simulate a cable harness along with the board to check for interference?
SI Wave does not have, as I said, it's a 2.5D solver, so it does not, it's mainly for PCBs. However, and that will be covered also in the next webinar for electromagnetic interference and electromagnetic compatibility issues. We can easily play with other tools of Ansys and mainly Ansys HFSS. And there, this is a 3D wave solver. So that way we can simulate our cable harness in HFSS, then simulate our PCB in SI Wave, and combine these two and have whatever information we want to see, either interference or crosstalk between the two. And we can also do this via the circuit simulator that is also built in.
Okay, thank you. And then the last question is if it's possible to organize a webinar about SI Wave project walkthrough, which I believe it's a question for both of us.
Yeah.
But yes, it is possible, but we cannot promise anything yet. But if we see that there is gonna be enough interest for any of the Ansys simulation solutions, yeah, of course, we are gonna organize a webinar or any other activity, and we will inform you about that.
Yeah,
I don't know, if you want to add anything.
No, like I think we can make a showcase of SI Wave to really show you how simple it is. Once you have your ECAD design inside, how simple it is to do analysis. As I said, a lot of the things are just one click. But yeah, it will depend, I guess, as Lisa said, on demand.
Yeah. Okay, these are all the questions we received. If you have any more but you couldn't come up with them during the webinar, again, feel free to contact us. You have our email address. And yeah, I hope we see you on May 22nd when we have our next webinar, but the invites and the other details will be shared with you as well after. So thank you very much. I hope you enjoyed, and yeah, see you next time.
Yeah, thanks everybody. See you next time.
See you.